As promised, saying that I'm gonna do example. So here is the example. It's from a PDF. Okay. So just to let you know, just now what I've explained in the previous lesson is, previous video is actually this all these things. Okay. I put it in my own words, and I hope I can let you understand it easier. And then this is the example. And just let you know, I didn't skip any page. Okay. From throughout, I didn't skip any page. Only some questions I skipped. But the theory part I didn't skip because this video is mainly focused on theories. And yeah, so yeah, so we have a 2 meter wide 4 meter tall rectangular gate, and it's being described over 4 meter, and it's hinged to pivot about the point 1. Okay, so this is hinged on the point 1. Maybe it's the seabed itself. So as shown in the figure below, determine the magnitude and location of the resultant force. So we are trying to find the resultant force and the the perpendicular distance from the origin. So if this well, as per we say before, we have to first define our force our resultant force using the very simple method. The very straightforward method, I would say, not simple. Force equals to pressure times area. Okay, and then after which later hold. Okay, but before I start, right, I need to clarify something. Okay, this portion, okay, as this is the previous video, okay, the picture. So PA is equals to, as we expand really, okay, this is the H is in terms of y sine theta, right? But if you expand area, right, it's actually V multiplied by dy. Okay, so this is the key thing I assume didn't show you. Yeah, so therefore when you bring out the b and then you put in the y, okay, so this y is actually like that. So you bring this y inside here and bring this b out, so you will have your force, your Fr as this equation. Okay, this is a very you know um terrible mistake I've made, so I hope that you can understand what I mean, and that yeah, so with this in mind, let's go back to here. Okay, uh this equation this problem says that okay, so you have to find Fr. So Fr is equals to the pressure, the water pressure times the area itself. So if you expand this portion, this is a specific weight of the water times H multiplied by a small change of dA. Okay, small change of the area. The area itself is the plane of, which is this area if it's 3D lah. Okay, let's show you. So therefore at, this is 9.8 times 10 cube. Okay, this thing is actually specific weight, not specific gravity. Okay, although specific gravity yeah, anyway, so this is specific weight, so be very extra careful. Okay, so specific is rho g ma, so rho g h it makes sense. So therefore when you expand and you know that h is in terms of y sine 60, okay, as the previously we actually defined. Okay, so this is the h and this is the y, right? So O divided by h is equals to sine 60. So this is O, sorry, yeah. So what the hell? What the fuck am I doing? Sorry, hold on a while. It should be the case. So hypotenuse, opposite divided by hypotenuse equals to sine 60. Okay, so hypotenuse, you bring it up, you can define what is the height h. Okay, so this is the height h. Okay, so don't be confused with my my terms hyp, hypotenuse, and the h height. This is what I did. And then the dA can expand to b dy, and then this b, because b is the breadth times the dimension dy, y. So as we say that this is the breadth, right? If it's 3D, so b times y is equals to the area, so it makes sense. So, and therefore, you just bring the b out and you bring the y in. So you sub in the values, and then you get this. Okay, so b itself is actually 2 meter as being defined, 2 meter wide. So if it's cm, you have to make sure you write is cm or meter. So in this case it's meter, so we are safe. And then you just sub in all the values. Okay, so it'll be like sine 60 and then y dy. So now this portion we didn't talk about is actually setting the limits for y. Okay, because just now we are actually dealing with the general equation. So from so far you can actually see that the general equation for finding the resultant force is actually this formula, which is true. This is also given in your notes itself, page 47. Yeah. So therefore, so now we are talking about setting the limits for y. So you have to say that from what to what. Okay, you have the limits itself have to limit into having the length 4 meter. Okay, so how do you want to set your limits so that you can have 4 meter? Okay, so you have from 6 to 10. Okay, right? From 6 to 10. Okay, maybe I should write down. Hold on. Actually, write down a new step. Okay, so is the key thing is setting the limits, making sure that it results in the 4 meter range, which is the 4 meter that we want. Okay, so from 6, okay, from origin 6 meter, okay, from 6 meter to 10 meter, okay. So this is how we set up. So the bottom is always from to something, okay, top is to something. So this is why 10 minus 6 is equals to 4, and therefore yeah. And then this, you may wonder why this is when we integrate. Okay, when we integrate this is half y square. So half y square is when you sub it in, okay, it shouldn't be 10 y square. Hold on, so it should be 10 square minus 6 square over 2. Okay, so yeah, because if you were to integrate y, you will have half y square, right? So you just sub in your y, so in this case it's 10. So I think you know what I mean. So this is a simple integration. Okay, and then we just keep this portion the same. Okay, the same, and therefore you just work it out. Just work it out. This thing, you eventually get your values. Okay, we hold on a while again. So you work it out. You have the resultant force. Okay, Fr perpendicular to the gate itself is 5.43 times 10 to the power 5 Newton. Okay, it may have some variation from the actual calculation, but this is the answer. So yeah, so we haven't finished yet. So we are asked to find the resultant force, and we did it by using the simple formula of force equals to pressure times area. You expand everything, and then you just solve for it. Okay, not also with standing that you have to know how to set up the limits in order to get the range for 4 meter for the gate lah. Okay, so now we need to find the resultant force, okay, which is deals with the torque that we're talking about. So this is the force, and this is the perpendicular distance from the pivot itself, I would say the origin. So it's Newton multiplied by meter is Newton meter. So therefore we can actually use the equation, okay, since this is inclined. But this is the equation that is for finding the YR, the position. Is the this form is what I have shown you over in the part over here. Okay, so as analogy says that this is the top, this is the top divided by force equals to the perpendicular distance. So we can actually use this formula. But however, we know that for incline, you can actually cancel out all the this sign thing. So you can actually straight away calculate for the integration part. So therefore, give me a minute. Okay, so as we mentioned earlier, so define YR position. So this is the equation as I say just now, top over force, okay, equals to perpendicular distance from the pivot, and therefore we cancel off the common terms. We have the integration for this case. Okay, so you just divide, okay, you just expand, you just integrate first, knowing the limits, okay, is 10 of it's from 6 meter to 10 meter. It's the same thing, okay, and then you do your stuff, you eventually get 8.17 meter, which is the correct answer. Okay, so just to summarize before I end everything is, first you find your force that is acting perpendicular to the gate, and then um, the equation itself you have to spawn it out. So it's F equals to PA. Apparently you can straight away use the general formula. Okay, the general formula is this one. Okay, where this is the breath, this is the rho g water, the specific weight of the water, sine theta, and So if they ask you to derive, at least you know how to derive, and then yeah, and then you will be eventually find Fr already. And once you find Fr, you can straight away find your YL position by multiplying Y into the force. When you're multiplying force, when you're multiplying a distance Y into a force, you're getting Newton meter, which is torque. So this also explains why we have torque. And then divided by force, the force Fr that we have found earlier equals to perpendicular distance from the pivot. The reason why we multiply in the Y itself is to actually set out an equation is pretty much nice, because the guy is pretty smart. You just multiply in Y into the variable Y, okay, in terms of integration. So after that yeah, it's pretty smart. So just let you know, this is the common misunderstanding within the whole thing, I would say. But once you clear this understanding, it is pretty much quite straightforward. So next video I've ended the portion over here, hydrostatic forces acting on inclined plate, okay, incline, and just to force again is that only when if you are to cancel this thing, is only for incline, okay. Don't do this for others, because you are taking the same amount of resultant force divided by, you're staying this. Yeah, I think you get what I mean. So for incline, you can do that, but for curved surface, please don't do that. Okay. And then next video we'll talk about for curved surface what we're gonna do. Okay. Similarly, it's the same thing, just that Fr itself we got. Hold on a while. So it's just an additional term. Okay, I just print everything out. It's just defining fx and fy. Okay. So resultant will be Fr. So after which, when you're finding the position YR is another thing. So maybe in the next video I'll just talk about it. So I hope I didn't complicate anything. So see you. Bye bye.